This is the true story
of 5 strangers
picked to be in an equation
how am I supposed to work in this kind of environment and have their values changed.
to find out what happens
when flow is disrupted
and things start getting real.
Bernoulli's World, Love 184. Wait, is it Bernoulli or Bernoulli?
Hi, I'm Z. Most people think I'm really, really hyper. I guess it's because I'm up and down all the time. I don't really understand. But you can really only get my true value from my origin, which I know sounds funny, and they're probably going to think I'm really weird for it around here. But we're just going to see how it goes. It's our first day, and I'm super excited.
Hi, I'm Velocity. I got a lot of meters to seconds to go, so I gotta go. Bye!
I'm pressure.
And then start singing.
It's pushing down on me. It's pressing down on you. Under pressure.
Hi, I'm Gamma. I'm specific weight. I'm the product of rho and gravity. That's about it. I'm gonna do.
What's up? I'm gravity. Don't really change too much. Pretty constant. It's usually how it goes.
I just don't get it. Like, I don't understand why P has to be there and then he's not. It's not my fault. I go up and down. I can't help it. It's just the way I am. And then what is going on with G? He just sits there. He never changes. He stays constant the whole time. Like, I don't know how we're going to survive living here in the Bernoulli equation if he's just going to sit there, because I'm going to go crazy. And really, what's this Bernoulli thing? Is it Bernoulli or Bernoulli? Like, I don't even know where to go with this. I just don't even know. And Gravity sure isn't going to know because he just sits there and does nothing all day. Velocity, she's just running around all willy-nilly. I don't even know what the deal is with specific weight, like he, or Gravity. I don't know what he is. He just chills out, and then there's pressure. Pressure, what's wrong?
I can't take it anymore, Z. Every situation we are in, you're up and you're down, and you just can't pick what value you are.
And like you're any better? Really? You're going to give me that right now. If we're in a free jet, you're non-existent. I'm not even going to be here. I'm pressure. But then we go to a tank and you're off the charts. Like, what are you? You're just weird. I don't understand you.
It's not my fault.
You sure about that?
What's up?
I mean, you know it's not my fault. It's all about location, location, location. It's where the fluid is located. If we're in a tank or a pipe, I mean, that's my thing. That's my jam. But if we're in a free jet, then I might as well not even be there.
What's wrong, V?
I don't know. I just hate when we get restricted.
What do you mean?
I don't know. It's always about the flow. Everyone always has assumptions about us. And if the flow is not steady or inviscid, then contributions must be made to us.
I know. If our flow is steady, then the acceleration is just due to your change. However, if it's not steady, it isn't just due to your change, but determines the acceleration.
Yeah, and if the flow is inviscid and there are viscous effects, then that becomes non-conservative and can't be utilized.
Guys, we gotta get over to Love 185, but how are we gonna get there?
We could use this channel.
But to do that, we have to find the flow rate. So the first thing we solve for is V2.
Whoa.
Okay guys, this is what we should do. We just have to go back to the Bernoulli equation. First thing we need to identify is that P1 is equal to P2. They're both on the surface here, and so they're both going to be equal to the atmospheric pressure. Thus, P1 and P2 will cancel out with each other. So we're left with V1 squared over 2G plus Z1 equals V2 squared over 2G plus Z2 plus A. The flow rate is equal to A1 V1, which must be equal to A2 V2. So now we need to get V1 in terms of V2. So So we're going to have V1 equals A2 V2 over A1. But since the base of the channel is the same all the way through, we're just going to have Z2 V2 over Z1. After solving for V2, we get V2 equals the square root of 2G times Z2 plus A minus Z1, all that over Z2 over Z1 squared minus 1. And then to get the flow rate, Q equals A2 times V2, which then is going to equal Z2 times our base times the square root of V, or times V2, which is the square root of Z2 plus A minus E1 over and that's what our Q is equal to.
Until next time on
Bernoulli's World!